Hi everyone, this is Mrs. GA, and today we're going to learn some new techniques for factoring polynomials. So before we start learning our new techniques, please pause the video and give this warm-up a try. And when you're ready, hit play to check your answers. Alright, so go ahead and check your answers. So you'll notice that this warm-up includes all the different methods for factoring that we learned for quadratics. So in part A, first you can factor out a GCF of x. Every single term is divisible by x. And that leaves you with a trinomial that is factorable using magic x. So you should end up with three factors, x, x minus 7, and x plus 1. For part B, we have a trinomial, but that a value is greater than 1. So remember, I use a grouping method for this. So you multiply your a and your c value to get negative 12, and then you ask yourself, what multiplies to make negative 12 and adds to make negative 4, negative 6, and 2? And so we're essentially going to be rewriting negative 4x as negative 6x plus 2x. So we're just rewriting it as two separate terms. However, it is important that we put the 2x next to the 4x squared. We put the negative 6x next to the negative 3. So you want to make sure the terms have something in common. So here, the thing they have in common is 2x, so you can factor it out, leaving you with 2x plus 1. These two terms, you can divide them both by negative 3, also leaving you with 2x plus 1. And if these two terms are the same, you can group the outer coefficients. And then the last example, here first you need to factor out a GCF of 3x, leaving you with x squared minus 9. And then hopefully you realize this can be factored more using difference of two squares. So here's your final factored answer. Okay, so the first new method we're going to talk about today for factoring polynomials is what's called the sum and difference of cubes. So this is kind of similar to the difference of two squares. It's for very specific cases and it has a formula. But here we actually have both a sum and a difference. Okay, so that's a little bit new, and these are all going to be perfect cubes. So for this to qualify, both terms need to be perfect cubes, and then it works either for sum or for difference. So when I'm doing a problem like this, once you realize that it's one of these two, look at your terms, and then you have to determine what your a and b values are. So essentially you take the cube root of each term, and then you just plug it into this formula. So for sum, it's a plus b times a squared minus a times b plus b squared. And for your difference formula, this is a minus b, and then it's a squared plus ab plus b squared. So here, again, in this first formula, notice the binomial has a plus and the trinomial has a minus. And for the difference formula, the binomial has a minus and the trinomial has a plus. So they're really similar, so make sure you don't get them mixed up because the differences are very subtle. Alright, so let's try a couple of these together. So here we have x cubed plus 1. So I see that it's two terms. This is a perfect cube, one is a perfect cube, and it is a sum. So we know we can use that formula. So first, we're going to find our a and b values. So if a cubed is x cubed, that means a is x, take the cube root. And for b, the cube root of 1 is simply 1. Remember, here's the formula that we will be using. So it's a plus b times a squared minus a times b plus b squared. So now we just substitute. So a is x, b is 1. A squared would give us x squared. And then here we have a times b, which is x times 1, and then plus b squared. 1 squared is just 1. And now it is fully factored. And if you did this correctly and you checked from the beginning for a GCF, this should always be your final answer. You should not be able to factor either parts more. And again, that's only if you check for a GCF at the very beginning, but you should be done after you use your sum or difference formula. All right, let's try another one together. So here we have two terms. This is a perfect cube. This is a perfect cube. It's actually 5 cubed is 125, so it's a good number to start recognizing. So we can use difference of 2 cubes here. So our a value is going to be x. Our b value is going to be 5. Again, that's the cube root of 125, or you can say 5 times 5 times 5 is 125. And our formula for this is a minus b times a squared plus a times b plus b squared. So now all we need to do is substitute our values. So we have x minus 5 times x squared plus a times b gives you 5x plus, well, your b value squared gives you 25. And this is fully factored. All right, this one a little bit trickier, but same process. So again, we need to check to make sure these are both perfect cubes. 64 is a perfect cube. It's 4 cubed, so that's another really good one to know. 27 is also a perfect cube. It's 3 cubed, so a good one to know. So this is difference of 2 cubes. So our a value, you need to take the cube root of both parts. So the cube root of 64, again, is 4. And cube root of x cubed is x. And for your b value, cube root of 27 is 3. Because, again, 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So now that we know our a and b values, we're going to be substituting them into the formula. I think it's really helpful to write out the formula each time. So 1, it will help you memorize the formulas, and 2, it just makes it easier to substitute. So here, our a value is 4x, our b value is 3. Be really careful for this next term. So we're squaring our entire a term. So that means we need to square the 4 and the x. A lot of people forget to square the coefficient. So 4 squared is 16, and then we have x squared, plus, now we have to do a times b, so 4x times 3 is 12x, and then 3 squared is 9. So just be really careful with those a squared and b squared terms if you have a coefficient and a variable. All right, let's try this one together. So you might look at this one and say, well, this is not difference of 2 cubes because 5 is not a perfect cube and neither is 40. However, hopefully remember there is a method we should always check for whenever we are factoring. We should always look for a GCF first. So this one, both terms are actually divisible by 5. So if you do that, leaves you with 5 times x cubed minus 8. Now, once you've done that, hopefully you then recognize that this, your remaining binomial, is difference of 2 cubes because 8 is a perfect cube. It's 2 cubed. So our a value will be x, our b value will be 2. So we will need to use our formula again. So it's difference of 2 cubes again, a squared plus ab plus b squared. Don't forget to write your 5. That's still part of your answer. It's a factor, so you need to write it first. And then we have a minus b times a squared plus a times b plus b squared. So again, something may not initially look like sum or difference of cubes, but if you use check for a GCF first, sometimes the resulting binomial can be factored more. So always check for that GCF first. All right, so I have this first one for you to try on your own. So please pause the video and give it a try, and then we will check your answer in just a few seconds. All right, so go ahead and check. So first, again, I list my a and b values, and here's my difference of 2 cubes. I think the term to check for would be this term. So remember, when we're doing a squared, you need to square the 3 and the x. So make sure you do have 9x squared. It's really common for me to see people, they would probably write 3x squared, so you have to square the entire term. All right, so here I have another you try, so please pause the video and give it a try on your own. Alright, so go ahead and check. This one again does not initially look like a sum of 2 cubes problem, but if you factor out the GCF of 2, you're left with x cubed plus 27, which can be factored using the sum of 2 cubes. So just make sure your final answer has that 2 out front. Don't lose your factor because it is still part of your answer. Alright, so now we're going to move on to our second new technique, which is factoring by grouping. And this method, or some of the steps of this method, should look familiar from when we learned how to factor more complex trinomials. So essentially, anytime that you have a polynomial with 4 terms, after you've checked for a GCF, you should always check to see if you can factor by grouping. This is the only method that works when you have 4 terms. So for factoring by grouping, essentially what you're going to do is you're going to group together the first 2 terms and the second 2 terms, and then you're going to see if they have anything in common that you can factor out. So when you group x cubed and negative x squared, we can divide both of those terms by x squared. That would be the GCF. So we're going to divide both terms by x squared, and that leaves us with x squared times x minus 1. Now, for the second 2 terms, there's nothing that that you can factor out more, so I'm just going to say plus x minus 1. So your goal when you're doing this is to hopefully end up with something like this, where you see the same factor twice. So if you do see the same factor here and here, you can take the coefficients of each of those factors. So here your coefficient is x squared. Here we don't see it, but we can actually write it in to help us. The factor, or the coefficient, is 1, and you can actually group the coefficients into their own factor. So this becomes x squared plus 1 times x minus 1. And now it is factored. And then you should check to see if you can factor more. Here you can't because there's no such thing as sum of 2 squares, so this is fully factored. You can also check your work pretty easily by multiplying out your binomial. So this gives you x squared minus x squared, or sorry, x cubed minus x squared plus x minus 1. So it gives you what you started with. All right, let's try another one together. So here, first thing I check for is an overall GCF. So there's nothing that all 4 terms can be divided by. But since there are 4 terms, we know to try to factor by grouping. If we can factor, that's going to be the one that works. So I'm going to group my first 2 terms together and my second 2 terms together and look for a GCF there. So my first 2 terms both can be divided by 5x squared. Make sure you're factoring out the largest value possible. So this leaves you with 5x squared times x minus 3. And then here, we can divide both of those terms by 2. So that gives us plus 2 times x minus 3. This is how you can tell that this method is working, because we do have the same factor twice. We have x minus 3 twice, which means we can take their coefficients and they become their own factor. So 5x squared plus 2 times x minus 3. Again, always make sure that you can't factor more after, and we could quickly check our answer. 5x cubed minus 15x squared plus 2x minus 6. Alright, so now let's have a look at this problem. So again, here there is no overall GCF, but there are 4 terms, so I know that I'm going to try factoring by grouping. So for my first 2 terms, there is a GCF of 2x squared. That's the largest thing I can divide both terms by. So we have 2x squared times 3x minus 2. And here, anytime this first term is negative, I'm going to divide out a negative as part of my GCF. Both terms are divisible by 3, so let's divide out negative 3. So we say minus 3 times 3x, and then be careful, this becomes minus 2. So again, we see that same factor twice, 3x minus 2, which tells us the coefficients will become their own factor. 2x squared minus 3 times 3x minus 2. Let's check really quick. This gives us 6x cubed minus 4x squared minus 9x plus 6. All right, let's try one more example together. So here, again, there's no overall GCF, but 4 terms tells us to try to factor by grouping. So our first 2 terms are divisible by x cubed. So you want to divide out as much as possible. So that leaves us with x cubed times x plus 1. Our second 2 terms don't have anything we can divide out, but it is x plus 1. So I'm going to give it a coefficient of 1. And again, since these factors match, the coefficients become their own factor, like this. Then, like I said, we should always check to see if we can factor more. So this problem, if you look, this first binomial that we get is actually sum of 2 cubes. We have x cubed plus 1. So we can factor this more. So here our a value is going to be x, our b value is going to be 1. And here's our formula again, a plus b times a squared minus ab plus b squared. So we have x plus 1 times x squared minus x times 1, which is just x, plus 1 squared, which is 1. And then we have that final x plus 1 here as well. Now you can leave your answer like that. If you ever see that you have the same factor being multiplied twice, we can write it like this. We can say x plus 1 squared, and then you still have to write your second factor. Again, this is just a different way of writing your answer. Leaving it like this is completely fine. This is just a little bit more simplified, I guess. All right, so I have a U-try for you guys, so please pause the video, give it a try, and when you're ready to check your answers, hit play. All right, go ahead and check your answers here. So again, try grouping. For the first 2 terms, your GCF is x squared. For the second 2, it's 4, and you do have that common factor, so you can group the coefficients. Now here, be careful. I know this looks like something you would like to factor, but remember, there's no such thing as sum of 2 squares. There is such thing as sum of 2 cubes, but you cannot factor sum of 2 squares. Alright, here is the last problem for this video. So again, please pause the video and give it a try on your own, and we'll check your answer in just a few seconds. Alright, so go ahead and check. The GCF of the first 2 terms is 2x squared. The GCF for the second 2 terms is negative 5. Remember, if that first term is negative, you should factor out the negative. And that leaves you with this, so you have the common factor of x plus 4, so your coefficients become the second factor. Alright, that's all for today's video. Thank you so much for watching.